Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating.
Welcome back, folks. We are on episode 3 of part 8, Weld Misalignment and Shell Distortion as found in API 579-1 or ASME FFS1. And we will reference 579-1 today in this presentation, specifically the 2007 and the 2016 editions. So we're going to talk about inspection and monitoring to begin with. Secondly, we're going to talk about remediation methods that API recommends to deal with weld misalignment and distortion. And lastly, we're going to talk about how to perform a remaining life assessment and some strategies that one could use with dealing with Part 8 issues. API says about in-service monitoring with regards to Part 8, weld misalignment and shell distortion. And basically they say it's not required unless the following cases. Case 1, an unusual corrosive environment exists and the FCA cannot be estimated, and the FCA is the future corrosion allowance. Secondly, the component is subject to a cyclic operation and the load history cannot be adequately established. The third one is if there's a level 3 assessment requirement, if and this is what they're saying, they say if a component contains weld misalignment or shell distortion with a groove-like or crack-like flaw. About in-service monitoring. Now, for example, you go through those cases in the previous slide, and we find that if it is required, then API stipulates that visual inspection and field measurements of the component's weld misalignment and shell distortion has to be performed at regular intervals. And they don't get into how many intervals are required. I mean, there are some sections in here in part 2, for example, where they start to talk about how to make a judgment. But at the end of the day, it's up to the inspector and the owner to basically decide the intervals. The second thought is the type of measurements that are made depends upon the procedure utilized. The owner's specifications in the assessment. But there's some recommendations that API makes a little bit further into the presentation here about inspection data required. Now, if one were performing a level 1 assessment, then the following essential issues or items are required. The future corrosion allowance, the FCA, the out of roundness, which is for cylindrical shells subject to internal pressures, typical example where this would be a concern. The maximum measured internal diameter, the minimum measured internal diameter, the nominal diameter, so the diameter that we're starting with, the ideal diameter, it's also referred to in API. We can look at the weld misalignment, the wall thickness, and the radial misalignment. And we've shown some of the terms here like radial misalignment, and those are all abbreviations and definitions found in part 8 towards the end of the chapter, where it just before all the diagrams start being illustrated, and there's definitions there. So have a look at that. a level 1 assessment, we jump to a level 2. There are a few elements, additional elements that we require. Specifically, we need to know the temperature. So that's the essentially the main operating temperature, the internal pressure, the external pressure, the allowable stress, the weld joint efficiency, and the component inner diameter. We're going to get more specific about level 2 requirements. So if we're doing a weld misalignment assessment, then in addition to the ones mentioned earlier, we need to look at the component wall thickness. We need to look at the component geometry, like the radiuses, the measure of the misalignment of one part to another, the characteristic length, how much is the part is affecting the overall structure, really, and then net sectional force F. And again, a lot of this terminology is found in episode 1. Lastly, the bending moment. Now to continue more specifically for the level 2 assessment requirements, this is for out of roundness. We would need to know the component wall thickness, the mean radius of the out of roundness, the local radius, RL, and the Young's modulus. A level 2 assessment requirements for bulges. The specific is a specific requirement for furnished thickness. There's a requirement for the minimum thickness at the bulge measurements, distance to the structural discontinuity. A method which is recommended by API in 579 for a way to determine the extent of peaking in a shell. So in this case, we have an orange here, a template, and we have a couple contact points. And from what I remember, this radius matches the vessel true radius, which is shown over here. So then in this case, when they put the edges down, the contact points down, which is outside of the weld area, then you can, and you balance them equally, you're going to get an A1 value here and an A2 value over here. Determining extent of peaking, the second step in the procedure. So basically we rock this template to the left side to a point where it comes into contact, and then we measure B1. We go to step 3 where we rock the component to the right to a point where it contacts over here, and the rocking point is there, and then we determine B2. A diagram shown of the recommended, vertical welds spacing that one could perform when they want to characterize, the shell peaking. And so we typically start from the tangent on the pressure vessel, and we work our way from one end. And the extent of out of roundness in a cylinder. So this can be quite complex, these steps. So in this case, this would be our B1, and that's our vertical distance. And so we take a number of points around this to characterize this. And we eventually we want to build a model where we show we find the measured center of the part, and then we compare that against the true center of the ideal, cylinder. And we break them down into individual components. And then there's some equations used to characterize the out of roundness on the cylinder. The remediation recommendations that could be employed. And this particular method, where we would be considering adding stiffening plates and lap patches. One of the things to consider, though, with that design is the geometry, the temperature, the loading conditions, the principles in the construction code, and the allowable stresses of the original construction code. Remediation is called mechanical means or hydraulic jacking. I've done this personally on with a coke drum, where they can have considerable problems with going out around this due to the severeness of the service. And so the strategy here is fairly straightforward. What they want to do is they want to bring the fabric the shape to within the allowable fabrication tolerances of the vessel or tank. And so what they'll do with hydraulic jacks is they reduce by bringing it closer to within the tolerances, or within the tolerances by hydraulic jacking, is they by achieving that, you reduce local stresses in the shell to acceptable limits. So consider the following items to consider in your procedure. The jacking arrangements. When one is jacking, they can't provide too much local stresses to the part, and so that has to be checked. The loading application, how the load is applied to the equipment. Is it a gradual, or is it just like a quick type of load? And those things have to be considered, because they can, the rate at which a load is applied or let go can add additional stress to a part. The next one is like, what kind of monitoring would be done to ensure that the loads are being applied properly, and also to ensure that there's no cracking development and so on. Conclude this presentation, we want to take a look at the remaining life assessment and some thoughts that API has. So consider the metal loss resulting from a corrosive or in a erosive environment. Consider, for example, for corrosion environments, you may need to include the future corrosion allowance. And also consider that the corrosion is a function of time, and it's recommended to consider a maximum allowable working pressure approach. And there's some ideas in part 4 of the standard if you want to see more. Now, the cyclic loading, some thoughts here. So level 2 assessment, they recommend going in the 2007 editions to paragraph 8.4.38 of Annex B1, paragraph B1.5, or in a 2016 edition, part 14. Now there's something else to consider. High temperature operation. If operating within the creep range of the part of the equipment, then the 2000 and the 2016 edition consider looking at part 10. Now this concludes episode 3.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.